The Earth needs no introduction. It needs no introduction in part because the Apollo 17 astronauts, when they were hurtling around the moon in 1972, took this iconic image. It galvanized a whole generation of human beings to realize that we're on spaceship Earth, fragile and finite as it is, and that we need to take care of it. But while this picture is beautiful, it's static, and the Earth is constantly changing. It's changing on days' timescales with human activity, and the satellite imagery we have of it today is old, typically years old. And that's important because you can't fix what you can't see. What we'd ideally want is images of the whole planet every day. So what's standing in our way? What's the problem? This is the problem. Satellites are big, expensive, and they're slow. This one weighs 3 tons. It's 6 meters tall, 4 meters wide. It took up the entire fairing of a rocket just to launch it. One satellite, one rocket. It cost $855 million. Satellites like these have done an amazing job at helping us to understand our planet. But if we want to understand it much more regularly, we need lots of satellites, and this model isn't scalable. So me and my friends, we started Planet Labs to make satellites ultra compact and small and highly capable. I'm going to show you what our satellite looks like. This is our satellite. This is not the scale model. This is the real size. It's 10 by 10 by 30 centimeters. It weighs 4 kilograms. And we've stuffed the latest and greatest electronics and sensor systems into this little package. So that even though this is really small, this can take pictures 10 times the resolution of the big satellite here, even though it weighs 1,000th of the mass. And we call this satellite Dove. Oh, thank you. We call this satellite Dove, and we call it Dove because satellites are typically named after birds, but normally birds of prey, like eagle, hawk, swoop, kill, I don't know, kestrel, these sort of things. But ours have a humanitarian mission, so we wanted to call them Doves. And we haven't just built them, though. We've launched them. And not just one, but many. I'm going to show you a video from just 4 weeks ago of 2 of our satellites being launched from the International Space Station. This is not an animation. This is a video taken by the astronaut looking out of the window. Gives you a bit of a sense of scale, our 2 satellites. It's like some of the smallest satellites ever being launched from the biggest satellite ever. And right at the end, the solar array glints in the sun. It's really cool. Wait for it. Boom! Yeah, it's like the money shot. So we didn't just launch 2 of them like this. We launched 28 of them. It's the largest constellation of Earth imaging satellites in human history. And it's going to provide a completely radical new data set about our changing planet. But that's just the beginning. You see, we're going to launch more than 100 of these satellites like these over the course of the next year. It's going to be the largest constellation of satellites in human history. And this is what it's going to do. Acting in a single orbit plane that stays fixed with respect to the sun, the Earth rotates underneath. They're all cameras pointed down, and they slowly scan across as the Earth rotates underneath. The Earth rotates every 24 hours, so we scan every point on the planet every 24 hours. It's a line scanner for the planet. We don't take a picture of anywhere on the planet every day. We take a picture of every single place on the planet every day.